Welcome to the CuScribe circuit board tutorial, where we will show you how to create a double-sided circuit board using the CuScribe. We will be using the Flatcam open source software to create print files for the bottom traces, top traces, through holes, and the cutout of our custom circuit board. We will then use CuScribe's control panel software to set up our machine and start printing our board. Software installation instructions are available in the Getting Started section of our website. After designing your board in Eagle, Altium, Fritzing, Multisim, or your favorite Gerber-compatible CAD program, export Gerber files for the top and bottom traces and an Exelon file with your through-hole data. Before exporting, make sure your designs are above and to the right of the origin in your CAD program. We recommend you use a copper board at least a ½ inch wider and longer than the board you are printing. Next, we open the Flatcam software where we will create our print files. We will be walking you through the standard printing steps for a double-sided PCB, but many other advanced options are available using the powerful Flatcam software. We start by opening our bottom layer Gerber file. Because we will be machining the bottom layer with our copper board flipped upside down, we will need the software to mirror or flip the orientation of these traces. Click on Tool and then Double-Sided PCB tool and copy the settings shown here. 2.25 inches represents the middle of the CuScribe's print bed. After hitting the Mirror Object button, we see the traces have mirrored successfully. These settings will always be the same thanks to CuScribe's double-sided alignment system. Now we are ready to have the software trace the geometries of our circuit. We return to our Project tab and select the bottom layer. Now we navigate to the Selected tab and set up our tool diameter. We will be using a 0.02 inch diameter bit for this cut. After clicking Generate Geometry, we see that the traces shapes have been outlined into what's called an isolation route. Returning to our Project tab shows the new layer ending in ISO. Now that we have captured the outlines of our bottom traces, we are ready to generate the actual cutting paths for the CuScribe. We select the new ISO layer and return to the Selected tab. The Cut Z tells the software what Z position to use when cutting the traces. The Travel Z specifies the height to use when moving between cuts. These should always be -0.3 inches and -0.1 inches. Later in this video, we will see how we achieve accurate final cut depths using the CuScribe's mechanical depth stop. The feed rate tells us how fast we want to cut. We normally use 10 inches per minute for cutting traces, 20 inches per minute for drilling holes, and 3 inches per minute for doing the board cutout. We also have a Feeds and Speeds webpage where we document recommended settings for your cutting tools. With the settings updated, we hit Generate and we see the paths the CuScribe will be taking to machine the desired traces. Returning to the Project tab, we now see our bottom CNC layer, which contains the final print paths for cutting the bottom layer. In the Selected tab, we export it and save it to the Print Files folder within our CuScribe control software directory. Next, we will create the top layer print file using the same steps, only this time we will not need to mirror our traces. After opening our top layer, we see that the bottom layer makes the display too busy. We will delete these layers since they are no longer needed. Now we follow the same steps as we did with the bottom layer in order to trace our isolation paths and then create and save our top trace print file. Next, we will create our through-hole print file. Through-hole data is stored in what's called an Exelon file. We will select File, Open Exelon. and select our drill file. Then we select the imported hole layer and click the selected tab. In the Tools section, we see the different hole diameters that were imported. Because we will be drilling all the holes with our 0.04 inch tool, we can hold the Shift key and select all the hole sizes. If you want to cut different holes with different diameter tools, you can save print files for each tool diameter. After inputting our cut settings, we hit the Generate button, which creates our CNC or print file for drilling the holes. We select the layer and save it. Our final print file will be the cutout. You can create the cutout based on a Gerber import, or you can let Flatcam create it based on another existing layer. In this case, we select our top layer and use the board cutout section to create a border around it. The software allows you to leave breakaway tabs. If you don't want tabs, set this to -1. The Generate Geometry button now creates the square outline of the top layer. We select this new outline layer and set the cut options as follows. Then we generate the tool paths and export them as we've done before. With our 4 print files exported, we can now open our CuScribe control panel software and start the printing process. After connecting the USB cable and power cable, we switch on the machine. Now we can connect to our CuScribe using the control panel. We will first cut the bottom traces. Before continuing, make sure your spoil board is clean and any defects are sanded off, so that we can stick our copper board to it. For bottom traces, we want to stick our copper board to the right side of the machine's bed using double-sided tape. Make sure the edge of the board is properly lined up with the print bed. Now we follow the steps outlined in the CuScribe control software. Each print requires setting up the correct cutting tool, the desired cut depth, and homing the machine prior to starting the print. We secure our 0.02 inch cutting bit by loosening the height control bar and tightening the drill bit set screw as shown. Now we will set the proper cut depth. After lowering the bar, we click the Move to Height Setting Location button, which will move the machine to the center of the cutting surface. You can also move the machine using the manual jog buttons in the control software, but make sure to lift the cutting bit off the copper surface before doing any XY moves, otherwise you will break the bit. The CuScribe has a height control bar that allows it to maintain a fixed cut depth for the duration of the print. For trace cutting, we want a very shallow cut depth. We will limit the cut depth to the thickness of a sheet of paper. Carefully lift the arm and place your paper below the height control post as shown. It is important that the depth control post is on the paper, but the drill bit is resting on the copper board. Once the height control bar is resting properly, tighten the height control knob, and lift the arm to remove the paper. Your drill bit is now set exactly a paper thickness above the copper surface, meaning the cut depth for this print will be equal to the thickness of that paper. Click the Home button in the control panel to return your machine to the home location. After loading our bottom traces print file, we are now ready to turn on the cutting tool and plug in our vacuum. Clicking Print presents us with a final warning to turn on our motor and vacuum. Failure to do so at this point may result in a broken cutting bit. We hit yes and watch the machine cut out our bottom layer. To print the top board layers, we need to flip the board over. We remove the board, clean the traces with a rough sponge, and add tape to the side we just machined. Then we stick it to the left side of the print bed. Make sure to flip the board in the direction shown. For the top traces, we can skip setting the height and changing the tool because we will be cutting the same shallow depth with the same tool. After homing, we load our top trace file, turn on our vacuum and spindle, and begin our print. Next, we will be drilling the holes. We secure our 0.04 inch tool and set the cut height to the thickness of our copper board because we want to drill the entire thickness of the board. We home, load our drill file, start our spindle and vacuum, and print. Finally, we will cut out our board. Again, we don't need to switch tools or heights because we still want to cut the full board thickness using our 0.04 inch tool. Once more, we home the machine, load our cutout file, start our spindle and vacuum, and print the final cutout. After a quick cleanup, we are left with our finished board. We hope you have enjoyed this tutorial. If you have questions, check out our Getting Started section or contact us at info@CuScribe.com.